All right, guys, audio good, everything good. Welcome to part two for what we're going to do for the FE Chemical Engineering Marathon. The last previous one we talked about air quality, we talked about water discharge, we also talk about noise. Now we're going to talk about toxicology, chapter 51. And I'm going to breeze through this. This is going to be a very, very short live a bit because the big one is going to be engineering economics, and I want to make sure we are all ready for it. Um, if I take a pause, please forgive me. I'm having a back pain due to an accident that occurred like 2 weeks ago. My back still hurts a bit. I'm going to the doctor and I hope I recover fast. Okay. Now, for the question we have for the first question of our toxicology, they say which of the following are the major pathway for the exposure to toxic agents? So, we want to expose the toxic agent. So, inhalation, correct, because you inhale it through your nose or organ. Ingestion, correct. Wound contamination. Wound contamination is a little bit tricky. Uh, but yeah, you it's a little bit tricky. Nope, I don't think so. Skin absorption, obviously yes, through sweat. So we have and IV. I will say I and IV, so it's definitely going to be B. Okay, B is our answer for this. For the second one, they're asking us a chemical A. So they say chemical A has an LD50 of 3 milligrams per Kelvin per kilograms, and B has 9 milligrams per kg. So chemical A, that means chemical A is definitely more toxic, obviously. Um, because you have a smaller LD to get exposed. So 1/10, it can be 1/10, 1/9 toxic as chemical B. No. 1/3 toxic as chemical B. No. 3 times toxic as chemical B. Yes. So D is definitely the answer. Lower the LD50, the more toxic it is. Okay. So 3 times because obviously is 9/3. So it's 3 times more toxic than this since it has a lower faster. So the next question we're going to talk about is already do the favor compared to last time. So I put where's the reference? I think I had a reference right here. Oh, okay. So the reference is right here. Let me close this tab right here. So I already put a reference for you guys for what we're going to use for this risks and toxicology analysis. Um, already found it in the manual because I noticed last video we're looking for it in the manual, but now we already have everything we need. Okay, something is off. BCF, yes, we got BCF right here. Is I'm in the right page? We do it live, guys. We do it live. Oh yeah, I'm in the right page. Okay, this formula I'm looking for the daily dosage formula because we're gonna use this a lot when solving this chapter. Okay, there's the main formula I'm looking for. And we're gonna use this BCF formula. So look at this formula very well because they said the bioconcentration factor, which is called BCF. So bioconcentration factor, also known as BCF, for mercury is approximately 500 or 5,500 liter per kilograms. This can be milligrams per kilograms too. So, well, yes, the concentration is liters per kilograms, and the concentration of mercury found in fish. So, mercury found in fish, the concentration of mercury in fish is 0.39 milligrams per kilograms. You know, these are both in different units. I want to convert them to parts per million. So we got to do a conversion to parts per million. So I'll talk about how we're going to do that too. So parts per million really have no unit. If you want to know, it doesn't have any unit. So it can be liters per milligrams per liter. It can be milligrams per meter cube. So it has no unit. So then we're looking for the concentration of mercury in part per million. That's what we're looking for. So the first thing we're going to know, we know BCF from what we have in our FE handbook. BCF is what? Concentration of CORG is equilibrium concentration of organism, and C is concentration of water. So in this scenario, our equivalent concentration of organism is the fish, and mercury is our solvent. Mercury, mercury is a BCF. And we're looking at what's the concentration in water. So we know we have the organism, which is a fish, and we're looking for the concentration of water from our formula. So the concentration of water is equal to this of organism all over the our BCF. So this is going to be 0.39 milligrams per liters, or 5,500 liters per kilograms. Okay, is it liters per kilograms? Okay, this is milligrams per kilograms too. This cancels this. So we're left with, our answer is going to be 7.091 times 10 raised to the power negative 5 milligrams milligrams per liter. So this can also be 7.1 times 10 raised to the power minus 5 ppm, because ppm can be any unit. Okay, so we solve the equation. Our next question is this one, and this one we're going to use a big formula. Okay, so pay attention, please. I'm just thinking about something. I'm just thinking about something. Okay, a village water supply was contaminated with benzene for 16 years. Okay, this was contaminated benzene for 16 years. So I always call it time span. Time span for contamination was 16 years. Okay, and they said the average concentration of benzene. Sorry, someone is texting me. Um, sorry. Let me check something. Oh shit! One of my friends just hit 12,000 followers on TikTok. You guys should go on TikTok, follow Patient Plastic. Um, Go on TikTok, follow Patient Plastic. He just hit 12,000 followers on TikTok. Crazy. Let me see. Yeah, he just hit 12,000 followers on TikTok. Follow him, Patient Plastic. He streams every day. Okay. Um, if I can pull it on the screen, I will, but I don't want to dox private information. Okay, guys. Let's continue. Let's continue what we're doing. So our lifespan is 16 years, and the average concentration of benzene in this period. So in this period of 16 years, the average concentration of benzene is 50 times 10 raised to the power negative 3 milligrams per liter. And they say the cancer slow factor for benzene by injection, I'll just call it slow factor, is 2.0 times 10 raised to the power minus 2 kilogram per day over milligrams. So this unit, pay attention to this kilogram per D divided by milligram. This is very important, okay? Because when we're solving this, we have to find the when we're solving for this, we have to make sure the CDI is the inverse of this of the CSF, which cancels to solve this. I'm going to talk about this more as we go in. And I said this is for the villages. Okay, the villages, the average time span for the villages, well, lifespan is 68 years, and the average mass of people in the village is what 72 kilograms, and the villagers drink 2.0 liter per days of water. This is what the villagers drink daily. Okay, so we're trying to find what is the most nearly the average villagers added risks of cancer. So we're looking for the risks. Okay, we're looking for the risks of cancer for the villagers. So in honest toxicology, the risks is equals to the dosage, okay, or the daily dosage must multiply by the toxicity, which is also known as CSF. Okay, so this risk is equals to the daily dose multiplied by CSF, also known as toxicity. In other book, this can be written as risk as CDI multiplied by CSF. Okay, so these two are interchangeable. So how are we going to get the daily dosage? Okay, daily dosage of CDI. So if we want to get this, we know from this tells us the formula for the daily dosage. It gives us the concentration, the intake rates, the exposure frequency, the what's it called? Everything here, just the formula for it. Or sometimes you can see it written as the formula can be written as CW multiplied by IR, which is the same strength, multiplied by EF, multiplied by ED, divided by BW, multiplied by 80. Now, the trick about this is that this is how I solve the question, and this is a short form of how I solve the question. The bottom part only deals with the villages. This part deals with the surrounding. Okay? You know, I divided this into the villages, and I'll call this the surrounding. Okay? I'll just put SOR for it. So the trick for this is that we're going to multiply everything in the surrounding, okay? And we're going to divide it by the time span and the mass of the villages. Because that's what all this bullshit is. And also, when we're multiplying by the surrounding, we're going to include the drink, which is the intake the villagers take, daily intake. We're going to impute it part of our multiplication. So all we're going to divide it is by the time span of the villagers divided by the mass, because this formula can be very tricky. But this is like a simple way of solving it. So if you want to find a CDI or daily dosage, you're going to multiply. But when we're multiplying, remember the dimension is very important. So when we're multiplying, now when we're multiplying, we also need to ignore this slope factor. And I'll tell you why we ignore this slope factor. Because honestly, everything I'm saying, if you go to the FE handbook and look at the formulas right here, it all makes sense. Okay, it all makes sense. Okay, it all makes sense. I will know the slope. The when we get, we're looking for the rigs, and the rigs is equals to, we're going to multiply the CSF, which is our factor. So this factor is not going to be part of this. Okay, it's very easy. Okay, so we're going to ignore this factor. I'm going to multiply everything and divide it by the mass and the time span of the villages. That's what that whole big formula is all about when we're solving for the rigs. So we're going to have that. This is just a short form of doing it. Like when you see rigs or anything involved toxicology, you don't have time to pull it up. That's just a short form of doing it. And you know, doing this F is all time. So we're going to have 50 times 10 raised to power negative 3 milligrams per liters multiplied by 2.0 liters by diameter multiplied by 16 years divided by what? 72 kilograms times 68 years. Years cancel years. Kilograms cancel kilograms. Okay, liters cancel liters. So our CDI is equals to 3.28268 times 10 raised to power negative 4. Okay, milligrams kg, the diameter. You remember, I say pay attention to this. This is the inverse of this. The reason why is that the Rix doesn't have a unit. Okay, it's more like deal with the person. It doesn't have a unit. So if you want to calculate the Rix, it's equals to the, remember what we say, it can be daily dosage multiplied by CSF, which is the factor, or we can say CDI multiplied by CSF. Okay. So we're going to have 3.268 times 10 raised to power negative 4 milligrams kilograms per diameter multiplied by what? Our CSF is 2 times 10 raised to power negative 2 kilograms. Sorry about that. Kilograms, the diameter over milligrams. So all these cancels, all these cancels. So our Rix is left with 6.36536 times 10 raised to the power negative 6, which can be 6.5 times 10 raised to the power negative 6, which is C. Mind you, I've solved all this before. That's why it's looking so fat. It's looking so fast. So anytime you have a question with rigs, you have to know the factor. And once you know the factor, you're going to separate it and you're going to multiply everything and divide it by the villagers or the people that are going to be affected, the factors that are going to be affected that we're finding the rigs for. So this is just a short form of doing questions like this. Okay. Um, we'll solve this, right? This is where we use the bioconcentration factor. I believe so. So we're going to do question 5. So question 5 is very similar to question 4. But in question 5, we are looking for the hazard index. And in the hazard index, the factor is RAFD, not CSF. Okay. It's very similar. Once we can find the CDI or the daily dosage, which is the hard part to get, depending on if we're looking for the risk or the hazard index, we either divide it or we either multiply it. Okay. Now for this question, they said, well, the community water supply. Sorry about that. I don't know why my phone is being blown up. So for this question, they said the community water supply is contaminated and the lifespan with potassium cyanide. And potassium cyanide, the lifespan for this is going to be 12 years. Okay. So the lifespan of, I call this, let me call this, let's use the surrounding SOR. The lifespan, or let's say we do it live, guys. So we say the time span is 12 years. And they say the potassium cyanide has an Environmental Protection Agency (EPA). Please know the meaning of EPA. It might come out Environmental Protection Agency. We also have to know um, VOC, volatile organic compound, like we talked about before. But let's keep going. They say the Environmental Protection Agency refer to a daily dosage of so they said the agency refer a daily dose of 50 milligrams. So we have the EPA standard has a daily dose of 50 times 10 raised to the power negative 3 milligrams divided by kilograms per day. So in the back of our head, okay, when we see this 50 multiplied by this, we know that's going to be our factor. That's why I say pay attention to the way this unit is going to be written. So I just call the EPA factor. I call the EPA factor. This is going to be the factor we're going to work with, which is going to be 50 times 10 raised to the power negative 3 milligrams kilograms diameter. We already know. So they say the concentration of potassium cyanide is the concentration is 600 times 10 raised to the power negative 3 milligrams per liter. And now we're going to deal with the people. So the person in the community, I'll just call the people or villages. So they say the people, they have a mass of 70 kg and a lifespan of 75 years. And then I give us, oh, these people they drink an average. So this is for the people, information of the people. Okay, this is what we're going to divide everything from when we're finding for the CDI. And you see they drink an average of what? 2.2 liter per diameter. So they say, okay, this is what they drink. And I said, okay, what is the hazard risk or hazard index? Sorry, hazard index or HI is equals to what? We'll go to our FE handbook. I'm looking for the hazard index. Yeah, BCF right here. So the hazard index equals the intake rate, which is equals to the same as our dosage divided by the RFD, which is the constant. So our intake rate, we can call the CDI over RFD. And we know how to find the CDI. And how do we know the RFD? This factor. I say pay attention to this unit. So this is going to be the same as our RFD. Okay. So let's find the CDI. Like I said, the CDI, the easy to is multiply everything divided by the mass of the villagers and the time span of the villagers. So with that, this is going to be because CDI is equals to CW multiplied by IR multiplied by EF multiplied by ED. This formula is on the FE handbook. The FE handbook did as daily dosage. You can get this. You can just look online or look at any of your chemical engineering textbook. I know there's one that's selling on Amazon for FE. You can look at that. You find it there. So we know from what we have, our CDI is equals to multiply everything 0.3. No, I don't know why it says 0.3. We don't have 0.3. I don't know what my head is going to. So we have 600 times 10 raised to the power negative 3 milligrams per liters multiplied by 2.2 liter per diameter multiplied by 12 years divided by 70 kilograms multiplied by 75 years. Now we have gotten that. We're going to solve for we have CDI. So CDI is equals to 3.017 times 10 raised to the power negative 3 milligrams per kilograms day. Now we have CDI. We are looking for the HI, which is risk factor. So 3.017 multiplied by 10 raised to the power minus 3 milligrams kilograms per day divided by 50 times 10 raised to the power minus 3 milligrams kilograms per day. So this is equals to 0.06034 or 0.060, and our answer is what? A. So that's how we solve it. We have to find the CDI, or the daily dosage of daily intake. And once we get that, depending if we're looking for the risks or we're looking for the or the hazard index, we either multiply or divide by the factor. And based on the factor, we have to pay attention. Most of the factor, they are either milligrams, kilograms per diameter, or they can be the inverse of it, like the last one was the inverse. So just pay attention to this. That's how we get the factor, because the hazard index and the risks doesn't have a unit, so they have to divide. They have to cancel each other. Okay. Question 6, the same stuff, but we're looking for daily intake from what I'm seeing. So we're looking for the dosage, which is CDI. So in this question, I'm gonna solve this real quick for you guys. So for this question, we have the concentration of carbon monoxide in air. So let's call it concentration. I'll call it surrounding. The concentration of carbon monoxide in air is 37 multiplied by 10 raised to the power negative 3 milligrams per meter cube. Now they're using milligrams per meter cube, which kind of similar to milligrams per liter concentration, mass over volume. And now they say the mass of the people. So I'm going to give space and put people. The mass of the people is what? The mass of the people is 68 kilograms. The lifespan of the people is, I'll make it T years, 65 years. And the people's daily, um, 65 years, live in a city for 2 years. So the time span of this whole, lives in a city for 2 years. So the time span for this whole issue, yes, 2 years, okay? And they inhale the daily inhalation. So that's a daily inhale is 0.46 meter cube per day. So this is what they do daily. And for an exposure frequency factor of 1, so we have the frequency factor of 1. So frequency, it doesn't have a unit, so we don't really care. 1. What is the daily dosage? So we're looking for the CDI. So we're looking for the CDI, but pay attention. Um, the daily dosage is always in days. So we have to convert this as in hours. We have to convert it to days because that's what we have. So we're gonna say our CDI equals to 37 times 10 raised to the power negative 3 multiplied by, give me a sec. I need to put in the unit. Milligrams per meter cube multiplied by 0.46 meter cube per hour multiplied by 24 hours per day multiplied by 1 multiplied by 2 years divided by 68 kilograms multiplied by 65 years. So this cancels this kilograms cancel nothing. Hours cancels hours. We are left with days. Um, so meter cube cancel meter cube. So once we do all these, we're going to have our CDI as 1.84, okay, multiplied by 10 raised to the power negative 4 milligrams, kilograms per day. So it's 1.8. So our answer is equal to C. Okay? I tell you, it's very easy. This toxicity is one of the easiest one in chemical engineering. Very easy. Um, which of the following disease should be special concern to environmental engineers when designing, operating, and managing water supply? So this must be a waterborne disease. Okay. Acquired immunodeficiency, syndrome, AIDS. Nope. AIDS is not waterborne. It can be sexually or something. We have Rocky Mountain spotted fever. No, it's not waterborne. Botulism, no, it's not waterborne. Tuberculosis, yes, tuberculosis is waterborne. So I is there. IV is there. Sorry. Legionnaire disease, yes, this is waterborne. I've heard about it. I really don't know what it does really, but I've heard about people having this. Hepatitis A, no, it's not waterborne. So I think the answer is gonna be is V and IV, V and VI. Uh, you know, Legionnaire disease is associated with the heat transfer system of water temperature and stagnant water. So I know it's caused waterborne. I think tuberculosis is also caused with waterborne. So hepatitis B is it waterborne, or am I? Is there something off? Because I didn't solve this. I just left it because I assume it's gonna be easy. Because my question is I can see V and I know it can be only V. So VI. Hepatitis A is it waterborne? Let me check that. I don't think it's waterborne, but let me see. Let me check hepatitis A and tuberculosis. Give me a sec, chat. Okay, my internet is acting up. Sorry, guys, the internet is slowing down. Yes, hepatitis A can be waterborne. Okay, tuberculosis. Let's ask tuberculosis because this one my confusion is. Um, Tuberculosis is not waterborne, so definitely the answer is gonna be B and VI. So that was my bad. So B is our answer. So hepatitis is waterborne. Tuberculosis is not waterborne. So it's just waterborne disease. It's probably something you're meant to know. Um, I didn't know, so I'm not gonna blame anyone. Um, but this it has the solution right here, but I don't trust the solution sometimes because sometimes it doesn't. It's not right. So I'm just gonna screenshot this, but I won't be looking at the solutions. But we can look at it. We really don't care. It's not right. So I'm gonna get it out of my way. I don't want to be looking at it. So for eight, according to OSHA, Occupational Safety and Health something, most nearly what is the minimum concentration of oxygen by volume of ventilation should ensure to be breathable? 19.5. This is a very standard. We are meant to know this as chemists, so if you don't know it, you cooked. So question nine, very similar for what we did. Okay, very similar for what we did. They say the village water supply um, contaminated with heptachloro, a class B carcinogen. Hope it's not your village that have this, but there's one village somewhere in the middle of nowhere that has this. So like all we have to do, we have surrounding and we have time span of 8 years. Okay, and we have the concentration of this carcinogen to be 0.03 times 10 raised to the power negative 3 milligrams per liter. And we have the slope factor. Now look at, pay attention to this unit. So this is going to be our factor. So our factor is what? 4.5 milligrams kilograms per day. Okay. Now for the villages, like it's so easy that all the equations follow the same format. So if you know each topic, I know where to search for each questions. I know how to solve it quickly. This exam is going to be a breeze. Okay. So for the villages, we have the time average lifespan of the villages are 67 years. And we have the average weight of the villages, M or W, anyone you want to use. 60 kg is not going to change anything, 68 kg. And we have the average rate of consumption. So I'll just call it dosage of villages, 2.0 liters per day. So these just follow the same unit. So like I said, what we're going to do, we're going to multiply all the information gave us in this divided by the villages. Ignore the factor because if it's risk, we're going to multiply by the factor. So we're going to have CDI instead of using this is just a way of understanding this big ass formula because some textbook they change it. So I don't want anyone to be confused. So it's going to be 0.03 times 10 raised to the power negative 3 milligrams per liter multiplied by 2.0 liter per day multiplied by 1 multiplied by 80. Okay, it is. So we're going to divide this by 68 kilograms by 67 years. So this cancels this. So our CDI is left at 10.54 times 10 raised to the power negative 8 milligrams kilograms per day. So we have our CDI. Now we should find the other risks for cancer. And risks, we're going to multiply the factor or CSF multiplied by the CDI because they're going to cancel. So risks is equals to 10.54 times 10 raised to the power negative 8 milligrams kilograms per day multiplied by 4.5 milligrams kilograms per day. Since it's the inverse, we'll just put -1, and they all cancel. So our risk is equals to 47.43 times 10 raised to the power negative 8. Which can also be 47 times 10 raised to the power negative 8 C. Okay, so C is our answer. And I'm getting kind of tired, but we're almost done. The show goes on. The show goes on, guys. The show goes on. I don't even know if I should be streaming FIFA because I always play Pro Club. I don't know if I should stream FIFA to just, instead of playing for fun, just stream it. Hmm. I don't know. Is there something I should do? Don't be playing FIFA and be streaming it. Because I see a lot of people streaming it on TikTok, but I don't know if it's the shit streaming it on TikTok. Because I like playing FIFA. So, but we'll see. We'll see, guys. We'll see. We'll see. I like playing FIFA and I like studying. I don't know if I should be doing everything online, but we'll see. Let me give a text to the group chat. So our next question is: a community water supply has had a benzene concentration of 2.5 milligrams per liter. So we have 6H6 benzene concentration. I'm having doing that. I'll just put conk. I'm deleting all this. So we'll see the concentration is 2.5 milligrams per liter. And we also have Over the past 40 days, over the past 40 days, in that time, community members do not drink the water, but do use the water for showering. Them English. An average community member has a lifespan. So we go to villages. An average community member has a lifespan of 75 years, and the weight is 71 kg. Each community member takes on an average of 10-minute shower daily. Okay, take up an average of 10-minute shower daily. How we gonna and has a skin surface area of 1.75 meters square. Okay, okay. The thermal permeability constant of benzene is 0.62 centimeters per hour. So this is the villager's information. I don't see any slope factor. So what's nearly the absorbed dosage? So we're looking for the CDI, the absorbed dosage. Okay, okay, exactly. The same stuff that we do. We have the villager's information. We're going to multiply everything divided by the villager's information. I'm not going to go deep into it. So we're looking for the absorbed dosage. Same stuff that we do. We have 2.50 milligrams per liter multiplied by we have 1.75 meter square area multiplied by 0.62 centimeter cm per hour multiplied by, so we're gonna, that's all we have, I believe. Oh, we have 10 minutes too. So we're gonna divide all these by our villages information. 71 kilograms multiplied by 75 is, but now we have to do conversion. We also have 40 days. So now we have to do conversion. Okay, I have to convert these minutes today. Okay, so convert these minutes to days. Just this all conversion, and we're converting this liter to meter cube. So 1,000 liter equals to 1 meter cube. 1,000 liter equals to 1 meter cube. So let's do our conversion here too. We're converting centimeters to meters. We're converting minutes to hour. And we're converting uh, years to because we're converting years to days. So once we do all this conversion, we're going to be left with 9.3 times 10 to the power negative 5 milligrams, kilograms per day. So AD or CDI. So it's all the same stuff, all the same way of solving. Remember, I solved all the equations using the same approach. I first found the surrounding and divided it by the villagers' what weight and life expectancy. The rest is just unit conversion. Very, very easy. And now we have gone through all the 10 questions we have under toxicology. Brace yourself because we have engineering economics. I'll tell you, I'm going to be very slow during the engineering economics because I want you guys to understand. We might spend like 2 3 hours solving all the equations because it's very important for us to understand it. Okay. Thank you guys for tuning in and see you.